Hello there and welcome to a brand new lesson. This is how Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at exterior angles of polygons. By the end of this lesson, you should be able to state the sum of exterior angles for any convex polygon. You should be able to calculate the size of an individual exterior angle for regular polygons. Take note, regular polygons. And due to that, we'll be able to differentiate between regular and then irregular polygons in terms of their angles. And finally, you should be able to solve algebraic problems, finding the number of sides using the exterior angles. So without much ado, let's quickly look into it. So let's start by looking at the magic sum we call 360 degrees. Now, irrespective of the polygon in question, the sum of the exterior angle is 360 degrees. And I'll show you with these three polygons we have over here. So for a triangle, let's say you are standing at this particular point, you see, and you want to move around this triangle we have over here. So we would have, if we were facing here, then we would have to turn to face this direction. So if you face this direction and you get to this point, you'd have to turn and then face this direction. If you get to this point as well, you'd have to turn and then face this direction. And that brings you back to where you were facing. You see? So as a matter of fact, what it has actually done is it has taken you round. So you were here, you were facing here initially. You had to face here, then you had to face this point, and then you had to come back here. That is a 360. You see? The same way, if I'm facing here, at this point, and I would want to move in this direction, I'll have to move this way. You see? So over here, whilst I'm moving this way, I would have to change my direction. I have to change my course. And as I get here, I would also have to change my course to face this direction. And then finally, at this point, I'll have to change my course to face this direction. So with that, you realize that you were initially at this point, you've gone around, and then you've come to be again at this point. That is a 360 degrees. And it is obvious that the pentagon here would also satisfy that same condition. So what is the magic sum 360? All we are trying to say is, irrespective of the polygon, the sum of the exterior angle equals 360 degrees. So now that we know this, let's look at the difference between a regular and an irregular polygon. Then I'll let you know why you need to know the difference between these two. To explain what regular and irregular polygons are, let's look at these two pentagons. We know it's a pentagon because it has 5 sides. So 1, 2, 3, 4, 5. That is a pentagon, you see. And then this is also a pentagon. So we have a 1, 2, 3, 4, and 5. But if you are to observe the two, what difference do we take note of? One major difference we see here is that if I'm to take one of the sides of the one on top, so I'm taking this side, for instance. This is it. Now let me make that red and then just increase it this way. So we see this measure. If I'm to align it to all the sides, you'd realize that it would be equal to all of them. So this over here, you see how equal it is. And it is the same as what you have here as well. So it is equal to this, and it is also equal to what you have here as well. So all I'm trying to tell you is that for this very first one we have here, all the sides are equal. All the sides are what? Equal. But if we take this second one, so if I'm to copy this very length, let me just deepen it and change the color. Now this side is not equal to what we have even at the right hand side. Let's start from the left hand side. You see, so it is not even equal to it. The same way, it is also not equal to what we have over here as well. And the same way, it is also not equal to what you have at all the sides. They are not equal. One thing we should note is that since all the sides are equal, then it also reflects on the angles. And we can also say it simply means all the angles are also what? Equal. But on the other hand, for this, whose angles and sides are not equal, whose sides are not equal, then we can infer that the angles are also not equal. What then is a regular and an irregular polygon? When we talk of a regular polygon, it is a polygon with all sides equal. So if it is a pentagon, then all the 5 lines or sides have the same measure. If it is a heptagon, then all the what? All the 7 sides are equal. You see, if it is a decagon, all the 10 sides are equal. That makes it regular. And if all the sides are equal, then all the angles are also equal. But for an irregular, even though if it is a 5 side, we call it a pentagon, yes. If it is a 10 sided, we call it a decagon, yes. But all the sides are not equal. Hence, we can say this is a regular pentagon and this is an irregular pentagon. You see the difference between a regular and irregular pentagon? Yes. So we can also infer that for a regular polygon, all the exterior angles are also the same. You see, all the exterior angles are the same. This is because since we know the interior angles are the same, we know for each interior angle, it has an exterior angle. If we have this as our alpha and then this as our beta, this alpha is the same alpha we have over here because they are all the same, you see. And that will simply mean that all the exterior angles as well will be what? Beta, because they are corresponding or their linear pair are the same. That is not so for irregular polygon. For an irregular polygon, if this is our A, this is different from B, and it is also different from what? C. It is also different from what? D. It is also different from what? E. And that simply means their exterior angles would also be different. So if these are E, then F is different from J. It is also different from what? H. It is also different from I, and then also different from what? J. Hence, we have a general formula for an exterior angle of a regular polygon. Now this formula goes like this. First of all, we know that the sum of all the exterior angles of the regular polygon is actually what? 360. So if sum of exterior angles is equal to what? 360 degrees, and we know all the sides are the same, then it simply means it is the sum of all these exterior angles that gives us the 360. So if you want each, you see, so if you want each, take note, this calculation we are doing here is for a regular polygon. So let me write that clearly. So for a regular polygon, then each exterior angle, so we have each being equal to what? The 360 degrees all over n. You see, where n is simply what? The number of sides. So the n is simply the number of sides of the polygon. So what happens to the irregular polygons? Take note. So NB. For irregular polygons, the sum of the interior the sum of the exterior angles sums up to 360, all right, just as for the regular. But the only thing is all the exterior angles are different. Hence, we don't use this to get the value of each and every one of them, no. But then we agree that the sum of all the exterior angles gives us 360. So let's take some examples and then solve to test our understanding. Our question says, this is going to be our first question. It says, we should find the size of one exterior angle of a regular pentagon. Take note. It says you should find the sum of just one of them. How do we do this? So remember our formulas we stated here. We said each exterior angle equals what? 360 all over n. You see? So we know first of all that the sum of exterior angles equals 360. Now since we want just one of them, and moreover because it is a regular, if it was irregular, there was no way we would have even gotten that. So because it's a regular one, then we know that each exterior angle is what? The sum of all of them, that is 360 divided by n. And take note, we said that n is what? 5. That is a pentagon. Okay. So we are then going to say each exterior angle, or the one exterior angle that it says we should solve for, implies we have 360 degrees divided by what? The 5. And 360 degrees divided by 5 gives us a 72 degrees. It simply implies that the size of one exterior angle of a regular pentagon is 72 degrees. As simple as that. Very straightforward. Let's solve some few more questions. Our question here says, a regular polygon has an exterior angle of 40 degrees. How many sides does it have? What does this mean? So if you look at the structure of the question, it says a regular polygon has an exterior angle. So it means they've actually solved for just one each. You see, and we know the formula for each. So our formula for each says each exterior angle is 360 over what? N, which is the number of sides. But we already have the each. So each exterior angle is what? 40 degrees. So it is the n that we want. So let's do our substitution now. It simply means a 40 degree is equal to 360 over n. And it is n that we want. So we apply our knowledge of fractions and algebra to make n the subject. Now you know this 40 is over 1. So what do? We choose to cross multiply. That is simpler. If you cross multiply, we have 40 times n. 40 times n gives us 40n. And that is equal to 360 times 1. So 360 times 1 gives us a 360. Let's continue right here. So we have 40n equals 360. What do? We divide both sides by the 40. So that this 40 cancels out this. And then we have n being equal to what? A 9. It simply means that the polygon has 9 sides. You see, it implies that, and that is just that. You see, there are so many ways the question can be asked. I always say, understand the concept. That is why I spend enough time explaining the concept. If you understand the concept and you are good with your algebra, you are good to go. Let's see another way. I think 2 more other forms these questions can be asked. So let's look at this one, and I think it is actually very simple. It says, if the exterior angle of a regular polygon is 30 degrees, what is the interior angle? Does this look familiar? Yes, it does. So remember, we said that is right from these figures. He said if you look at the interior and then the exterior angles, they form a straight line. You see, so this straight line make them form what we call linear pairs, and linear pairs are actually adjacent angles that are supplementary. Their sum equals what? 180 degrees, and that is what we want to apply right here. He says you should find the exterior angle of a regular polygon. Sorry, if the exterior angle of a regular polygon is 30, what is the interior angle? So we know that exterior plus interior equals 180. So that is what we have here. And we also know our exterior angle. So our exterior angle from the story we have here is 30 degrees. So substituting, we have exterior angle, which is what? A 30 degrees, then plus the interior angle. Let's just make that an I, equals 180 degrees. It's all about making I the subject. So our I is equal to a 180 minus the 30 degrees. 180 minus 30 gives us a 150 degrees. As simple as you see. You see, so it simply means the interior angle is a 150 degree. Now you'd realize that all these that we've been solving on are on regular polygon. There are questions that can be asked even on irregular as well. This last one will be on irregular. The very last question here says, an irregular quadrilateral has three exterior angles of 80 degrees, 100 degrees, and then a 90 degrees. And then we have to find the fourth exterior angle. Does this sound familiar? Yes, it does. Now we have been given, it is actually a quadrilateral. A quadrilateral would have four exterior angles, but we just have three over here, and we want the fourth one. Now we know that assuming we have the fourth one, then the sum of all these four should give you a 360 degrees. That is the sum of the exterior angles. So we can write something down. So we know that the sum of exterior angles is equal to what? 360 degrees. Now what are the exterior angles we have? We have what? 80, 40, and then 90. So let's let the fourth exterior angle be what? A variable. So we are going to let it be what? Y. Then adding all these three to the y, we have 80 degrees plus 100 degree, then plus a 90 degree, and finally plus the y. And that should then give us what? A 360 degrees. 80 plus 100 gives us what? A 180. Then a 180 plus a 90 will give us a 270. So we have 270 degrees plus y being equal to a 360 degrees. Making our y the subject, we have y being equal to 360 degrees minus 270 degrees. Our y is then equal to what? 90 degrees. And that becomes the angle of the fourth, that becomes the measure of the fourth exterior angle. So that is that. We'll end this lesson here, but as usual, I would leave some exercises for you to test your understanding. So here are 5 questions You can try on your own based on all that we have done in this lesson. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know at the comment section, and when I'm notified, I'll be addressed. It will be addressed for you. This is how Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel and you think it would be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Stay safe.